Algebra 2, Unit 3, Lesson 1, Part 5, and the critical part is it's the last part. So we have parked ourselves in Lesson 1 for several class periods, really trying to cover this material thoroughly, and you know that that is what I said we would do at the beginning of this lesson. So the first question we want to consider in this particular lesson is, why is factoring so important? If we spend 4 class periods just learning how to factor, then this must be an important skill, okay? Because we would not spend this much time learning how that area model works and sorry, I'm getting text messages. So why that area model works and why we can factor with the base times the height. Why do we spend so long on that particular skill? Well, the answer is it is one of the primary ways that we solve quadratic equations. So ultimately, factoring just for factoring's sake is not really relevant. Nobody in real life just sits down and says, I would like to factor something. I wonder what multiplied to give me this quadratic expression. No, in any kind of extra math class application, you have a relationship. That relationship is quadratic, and you need to find something in that relationship, in this case, namely the x. And one of the primary ways that we solve quadratic equations is through this process of factoring. In fact, the factoring process is preferable to some of the other strategies. So we do have other strategies for solving quadratics, and factoring is often the preferred strategy because it is cleaner, simpler, and can lead us to being able to simplify other kinds of expressions as well. So we want to review some key ideas here. Okay, key ideas. I know that vocabulary can be dry, but this is the stuff that doesn't change. Shortcuts can change. So you have a shortcut for graphing a line, but it doesn't work with a parabola, or a shortcut for finding the slope, but it doesn't work for something else. We don't want to focus on shortcuts. We want to focus on key ideas that hold true from one lesson to the next lesson to the next lesson and into the next unit and into the next year of math. So one of those key ideas is what is a quadratic equation? That is never going to change. The key idea in a quadratic equation is quadratic equations have an x squared. And earlier when we defined this, we defined it more specifically as they have an x squared. They don't have anything higher, so there's no x to the third or x to the fourth. And there's a couple of other things that are important that we don't really get into at this point, just because it muddies stuff. So you can't have an exponent that's a fraction. You can't have an exponent that's a decimal. And we haven't even talked about what those things are. So it probably hasn't occurred to you that those could be things. The other thing I want to drive home at this point is there also has to be an equal sign. Okay, and that goes into the idea that we are looking at an equation. So I really want to emphasize this right at this point, is that a quadratic equation has to have an equal sign because it's an equation. It is different from a quadratic expression, which is what we've been working with. So just so you can see the difference for yourself on this. Okay, a quadratic equation might be something like x squared plus 2x plus 4 equals 5. Okay, that might be a quadratic equation. A quadratic expression would just be x squared plus 2x plus 4. And there's no equal sign. You don't know anything about what that expression is equal to. So on the left here, we have a quadratic equation. It's got the quadratic, the x squared, it's got the equal sign. On the right, we have a quadratic expression, and you can't solve an expression. If somebody asks you to do that, then they don't know what they're talking about, okay? Can't solve a quadratic expression. You can solve an equation. Other key idea here is, and we talked about this last class, so that's why I want you guys engaging in the warm-ups, because the warm-ups prep you for what's coming. A solution. Solution is the values of, now typically I'll put in there the values of the variable to keep it more generic, but for the interest of brevity, I guess we'll just say the values of x that make the equation true. And in one of my classes, it was actually a class that met today, in the previous warm-up, we had a bit of an issue because students were doing the wrong thing. And what it came down to is knowing what you're being asked for when you're asked for a solution. When you're being asked for a solution, you are being asked for the values of X that make the equation true. Now, why that's so important to know is because that is true for linear equations, quadratic equations, exponential equations, equations that you have never heard or seen of, okay? If they don't have an X, maybe they have an A, a B, an N, okay? A theta, okay? We get into some like weird stuff, but it's the value of the variable, whatever that variable is, that is going to make that equation true universally all the time. It doesn't matter whether you're in Algebra 2 or pre-calculus or whatever you might be in, taking the SAT. When you are asked for a solution, that is what you're being asked for. You haven't answered the question until you find the solution. Okay. So the key property that we're dealing with, I'm going to find my pen. The key property is something called the zero product property. Okay, take a moment and put that into your notes. The zero product property. That is our key idea. And again, we want to focus on key ideas, not shortcuts, not processes. We want to know these ideas behind why these things work. Okay, if you know the idea, you won't forget the process. So first, in all of its interestingness, we're going to break down the words. So zero product property, what does that mean we're looking at? What does it mean we're talking about? So what does it mean? Okay, here's what the zero product property means. If A times B is equal to 0. Okay, now let's go look back up here and look at the words. 0 means that the answer, okay, or I'm gonna say that the answer, but I just want to be careful about how I say this. Let's see. Well, there's a 0 on one side, and product means, so this is not my greatest hits happening right now. And product means that we're multiplying, because that's what product is. Product is the results of multiplication. Okay, so zero product property, and now you can see it here, means you have a 0 on one side. Usually it's on the right. I kind of tried to shy away from saying it has to be on the right. It doesn't have to be on the right. But 0 on one side, and then a product means you're multiplying. And so here we have A times B. So if you have two things and you multiply them and the product is 0, then either A is equal to 0 or B is equal to 0, possibly both, which is not how you spell possibly. That is called, I looked at it earlier and I had the wrong thing in there. Like I had possible both and I added an ly and wasn't paying attention. There we go. That's better. It's not really like that much better, but you get the idea. So that's what the zero product property means. So yeah, allow yourself to think about it for a second. Don't rush through the video. Don't rush past this. Two things multiplied, and you know the answer is 0. What we are saying is that if that is true, one of those two numbers has to be 0. So you could think of it this way. You could have A times 0, which would give you 0. So it could be the B. It could be the A, 0 times B is equal to 0. That would also work. Or you could have 0 times 0. That's not usually the case, but you could have 0 times 0. Okay, that can happen as well. But what can't be is if you have not 0, okay, some number that's positive, some number that's negative, okay, and you multiply that by something that is also not 0, then that is not going to be equal to 0. If both of the numbers were positive, you would have a positive. If both of the numbers were negative, you would still have a positive. And if we had one of each, you'd have a negative, but you're not going to get 0. So that's your zero product property. That's what that property says. So to illustrate it, in the first equation, we have 3 times x is equal to 0. So 3 times something is equal to 0. Now, most of you would not use the zero property to solve this. Most of you would do this. You would say 3x equal to 0. That is multiplication. I undo multiplication with division. And 0 divided by 3 is 0. Okay, and so x would have to be 0. And that's the only thing x could be, because if you do 3 times anything else, you would not get a 0. X has to be 0. In the second one, you've got x, okay, and then you're multiplying that by x plus 3. And what the zero product property says is that one of those two things has to be equal to 0. So it could be the first thing, x is equal to 0, or it could be the second thing, which is x plus 3. And then you can solve that, and we get x is equal to negative 3. And then in the last one, there's something's going to pop up in the bottom there, so I'm going to move this over here. We have two things being multiplied. We have x minus 2, and that is multiplying 2x plus 1, and the answer to that is 0. And so the zero product property says one of those two things being multiplied has to be a 0. And so it could be x minus 2, or it could be 2x plus 1. And then you solve each of those as just a garden variety equation. So x could be equal to 2. On this one, you would subtract the 1. Okay, and then divide by 2, and so you could get x is equal to negative 1/2. And you have these two answers. And like with both of them, if you were to plug in like x equals 2, you'd get the 0 here, and this would end up being 5. Okay, but 0 times 5 is 0, so it works. On this one, this would end up being negative 2.5 times. Now you get the 0 over here. So negative 2.5 times 0 will give you 0. So both of those numbers work as a solution. Now I want you to notice something about all of these. Note in all of these examples, the left side was factored. Okay, and what you can't see under my head is, and the right side was equal to 0. Take a moment and let that fact just digest in your head. The left side was factored. Remember, we're going back to those words. Factoring means find the things that are multiplied to give me whatever I have. So right here, you factored 3 times x. In this one, it's factored with a GCF. So x times x plus 3. And in our last one, we have x minus 2 times 2x plus 1. All of them are equal to 0. And on the right-hand side, you have a 0. And that's because this property doesn't work with any number other than 0. And there was a question in your last warm-up that led you into thinking about that. Like, would this work with another number? It actually doesn't work with another number. And we could explore that a little bit. Suppose you had a, well, not that one, but like this one, if you had a 6, well, you could have like 2 times 3 or like it. Now there is a solution for it, but you would have to do a lot more steps to figure out what it was. Okay, you could solve it, you could guess and check, you could play around with that. But this particular property only works if you have a 0, because if you have another number, say a 6, well, I don't know, is this 2 times 3? Is it 1 times 6? If this is 3, this has to be 2, and it gets super, super messy. But with the 0, it's like one of the sides has to be 0, one factor has to be 0, and you don't even care what the other ones are. Okay, it doesn't matter. That only happens with 0. All right, so what does this mean for solving equations? How do we tie all of this together with what we've been doing? If we set the right side equal to 0, and I'll just toss out, it doesn't have to be the right side, it just has to be a side. We just often will use the right side. And factor the left side, okay? Again, it could be the right side, okay? Just 0 on one side and then factor the other side. We can use the zero product property, and I'm going to abbreviate zero product property as ZPP. So let's work through an example. Okay, and I think if I'm looking on the side here, I think I animated this with the different steps. Maybe. Not by doing that though. That works if I'm got a mouse. Okay, so we're going to set the right side equal to 0. Sometimes teachers will express this as get everything onto one side or move everything to the left side. Maybe you don't want the left side all the time. If it's going to make your x squared be negative, you might want to move it to the right side. But so we've got the 3x squared and the plus 20 on the left. I've got a 17x on the right, and what I want to get is that right hand side equal to 0. So what I will do is I will subtract the 17x. Now, when I go to subtract 17x from the left, because whatever you do to one side, you have to do the other, I'm going to subtract it like in the middle. So I'll do a little scratch work off to the side here. You could do this, plus 20x minus, or plus 20 minus 17x. That is technically correct. However, that is not in standard form where you have ax squared plus bx plus c. To put it in standard form, you want that 17x, or in this case, negative 17x, in the middle. Okay, and so what I'm going to do is instead of doing that extra step, I'm just going to put the 17x into the middle. So we will have 3x squared minus 17x plus 20 is equal to 0. Next step is to factor the left. And that's why we spend 4 class periods on factoring, because we need a way to get this left-hand side factored. So the first thing I'm going to do is look for a common factor. I do not see a common factor. 3 is a prime number, 17 is a prime number, so we are out of business, okay? And we don't have a common factor of x because the x was not multiplied all the way through. So what I'm going to do over here is some scratch work. I'm going to set up my area model. And I'm going to put 3x squared in the upper left and 20 in the lower right. And now I just have to grind this out. So I have a leading coefficient. So I do have 3x squared and I have the 20. And I need to make sure all of these squares add up to the right area. But in order to get the right candidates for that diagonal, I need to use both the 3 and the 20. So really quickly, I'm going to do 20 times 3. Which is going to give me 60. And I have to take the factors of 60 and find the pair that add up to negative 17. Some of you, you're going to see it right away. Some of you are going to reach for a calculator. Both of those are fine. Because this is a video and I'm illustrating some stuff, I'm going to factor it out like so. So factors of 60, never overlook 1 times 60. I know 60 is even, so I can do 2 times 30. Now remember, I'm on the lookout for something that will give me the 17. Then it's divisible by 3, and I get 3 times 20, and I can get a 17 out of 3 times 20. I can get there. If I use a negative 20 and a positive 3. And now we just need to factor it. So we can pick any group of 2 that we want. We can pick this group, or this group, or this group, or this group. I kind of like this group because there is no common factor, which means that the common factor had to have been 1. So if they don't have anything in common, the best you can do is factor out a 1. You could also look this way and you could see, oh, they have a 3 and they have 1x in common. So you could put a 3x up there. You could factor it this way, where all they have in common is an x. Okay, you can really start. I would not start with this one just because it's hard to know what to do with the negative. Okay, like should you factor out a 20 or a negative 20? That is not always easy, so I try to avoid that. But this one does not have a common factor, so I'm going to go ahead and factor out the 1, and then if this is 1 and the area is 3x, then the base had to have been 3x. And then right here, if this base is 3x and the area is 3x squared, this would have to be x. And then coming over here, if this is 20 and this is 1, this would have to be 20. Oh, wait a minute. Something is not right. I'm looking. It's not the right pair of numbers. 4 times 15. I needed 5 times 12. And now I'm debating, do I want to leave this mistake in here? Because some of you have already written it. Okay, so I think I'm going to leave the mistake in here. Not because I'm super proud of it, but because I think it might be a valuable lesson for you to see what just happened, and just kind of see what I missed and then what I did. So my apologies if you've been filling out your notes, but and I could go back and re-record it and clean it up. But sometimes I think you guys see me do a problem, and I wrote this problem, so but sometimes I think you see me get the problems right all the time, and you never see me make a mistake because I always make sure I have everything perfect before not that my lessons are perfect, they're not, but I iron it all out, and I probably won't do this in class because I just did it right now. But okay, so let me back up a little bit. It's going to make the video a little bit longer, but I hope it's worth it for you. So what I noticed as I was doing this is that my areas didn't check. So I was going to say, if this is 1 and this is 20, this would have to be a 20. Okay. Before I had a chance to write it, I noticed that this box doesn't check. 20 times x doesn't give me negative 20x. And you could rewind it if you want to hear it in my voice. I realized, oh my word, this doesn't check. So immediately I went back and I wanted to make sure that yes, this added up to the right thing, and make sure that I had copied the problem correctly from over here, that like it wasn't anything like that. And then, again, you can rewind it and see the wheels turn. What I did was this. I said, well, maybe 3 times 20 isn't the right combination. Maybe I need something else. So I started to do this. I started to say, okay, well, we could have 4 times 15. That does not give me a 15. But then the next one is 5 times 12. And that will also get me the 60, and I can get the 17. So what happened there was there's actually 2 pairs of numbers that I could get the 17, and I picked the wrong one, and I didn't catch it until this didn't check. Maybe if I was like fresher. So again, we're not panicking. We are not like, we check for the typos. We don't say, I can't do it, I'm stuck. We go back and see, what did I miss? Did I miss something there? So now that I see it, I'm going to erase these pieces because I know this is a mistake. And I'm going to fill it in with 5x and negative 5x and negative 12x. Okay, so that will also work to get you the negative 17. And again, like I kind of like part of me just wants you to see like how I handle that. So just go back and see what did I miss. So same process that we did before. Hopefully it'll work this time. Looking this way, I'm going to try this way. 3 and 5 don't have a common factor, but x squared and x do. And so that will give me x, okay? And then we'll see if it fills in a better way. So if this is x and the area is 3x squared, then this must be 3x. And then coming over here, if this is x and this is negative 5x, this must be negative 5. And then right here, negative 5 times what would give me positive 20? That must be negative 4. And then this is what I caught last time because it didn't work. If I do 3x times negative 4, it's negative 12x. And so now all 4 of my boxes work. And that's what you're driving for. And what a lot of you in class, like you're not getting all of them to work. And so instead of deleting it and just redoing the whole slide with me getting the right answer the first time, I did leave it in there. It's a little bit embarrassing because just like you, I don't really want to get stuff wrong, but I don't know. I hope you found it worthwhile. I'm sorry if it meant that you had to erase some stuff. Hopefully not too much. Okay, we didn't have to erase too much there, but to just kind of see where do I go back to, what kinds of things, what kind of questions do I ask myself, and then yeah, how to keep going with it. So now we've factored the left. Okay. And here are the factors. So instead of writing them down here, I'm going to come back over here and write them. I have 3x minus 5 and x minus 4. And then don't forget that equals 0. That equals 0 is part of the equation. Okay. And then use ZPP, use the zero product property to solve. And the zero product property, again, tells us that if I have two things that are multiplied together and that product is equal to 0, then either the first factor was 0 or the second factor was equal to 0. So it's either 3x minus 5, that could be equal to 0, or x minus 4 is equal to 0. We'll solve this one first because it's simpler. So add 4. You do not have to write plus 4 plus 4. Okay, don't need to write it. On this one, we add 5. And so we get 3x is equal to 5. And then divide by 3. And I'm going to see if I can squeeze it in there. X equals 5 thirds. And there are my two answers. Leave it as a fraction. All right, so that slide took longer than expected. Yeah, it is what it is. Pause it. Don't rewind it the whole way. If you need to see it, just rewind it back to where I caught that mistake, okay? If you need to see it, or just pause the video and study the solution. Let yourself look at it. Make sure you're copying it. All of those things are going to contribute to your learning and your ability to remember things. Okay, so example 2, try this on your own for 5 minutes and then we'll review. So if you're doing this from home to make up the lesson, what I want you to do is, sorry, I just noticed something about what's about to happen on the screen. Pause the video, make sure you work on this for at least 5 minutes, and then we'll look at it together. Okay, hopefully you did that and you are not just letting the video run, because I am not going to do this for you on your test. So you need to try it on your own. So the first step was get the 0 on one side. And as you can tell in this particular problem, we already have the 0 on one side. So if somebody is willing to do some of those steps for you, take it, okay? Then we want to factor the other side, which is often the left side, but not always. And so this one's a nicer one for us to factor. So we will set up our area model. We'll put the x squared in. We'll put the 18. So you probably look at this and say, oh, good, the x squared, that's not a bad one. So we look at the 18. Now, if you want to remember, we're still doing that like a times c. We're still doing 1 times 18, except 1 times 18 is just 18. So that's why we don't bother doing the step. So we look at 18. 18 could be 1 times 18. It could be 2 times 9, or 3 times 6. And of course, we're looking for something that adds up to 9, and we know that the answer is going to come off of that list, which in this case would be the 3 and the 6. So we'll go ahead and put that in, and then we can factor it. This is nice. If you get the x squared, it only factors one way, so you don't have to worry about it. This would be a 6. This would be a 3. And so our factors are x plus 6 and x plus 3. And now we apply our zero product property. So I have two things. Those two things are multiplied together, and the product is 0. So either the first or the second. So it could be x plus 6 is equal to 0, or x plus 3 is equal to 0. And we subtract 6, and we get x is equal to negative 6. Or we subtract 3, x is equal to negative 3. Now, just to reinforce one step here, is the idea of what we're doing. And so remember what a solution is. A solution is the values of the variables that make the equation true. So just for fun, what I'm going to do is try out the negative 3 just to see what happens. So our equation was this. Our equation was x squared plus 9x plus 18 equals 0. So if I do negative 3 squared plus 9 times negative 3 plus 18, that should equal 0. Negative 3 squared is negative 3 times negative 3, which is positive 9. Positive 9 times negative 3 is negative 27. And then we have plus 18. And if you grab your calculator and you do 9 minus 27 plus 18, you will get 0 equals 0, which of course is a true statement. And so I know that negative 3 is a solution to that equation. All right, so I hope you were at least moderately successful with that, or if you were not, that you feel like you could be now. Now, the last topic we need to cover here is how could we verify our answers by graphing, or maybe how could you even solve it by graphing? So if you didn't want to do the factoring, or you couldn't do the factoring, or you did the factoring to solve it, but you're not sure you solved it correctly. So what could we do in that case? So let's explore it. We have the graph or the equation x squared plus 9x plus 18 equals 0. And we already know that the answers are negative 3 and negative 6 because we solved it algebraically. So what we're going to do is graph it and then look at the graph. And the question is, where do you see the answers on the graph? So I got to remember how to do this. And my face is still there, which is super weird. Okay, so let's go and type in x squared plus 9x plus 18 equals 0. And there is a parabola there. It's a little hard to see. I've got the Desmos window kind of shrunk down a bit. But take a look at that. We know the answers are negative 3 and negative 6. Where on that parabola do you see the answers? I'm going to pause the video and give yourself enough time to look at it. Okay, what I hope you noticed is that they are located right there and right there. They are the x-intercepts. Okay, they are the x-intercepts of of the parabola. And so you can see the -3 and the -6. Now, just because you see it one time does not mean that that is all the time thing. It could be a coincidence. You always kind of want to keep that in mind. Like, is that a coincidence? Is that something that just happened with this equation? So the next thing is I want you to try this one and see if it works. Pause the video, hop on over to Desmos, and do that one out, okay? Do 2x squared minus 17x plus 21, and then use what we just discovered there and see what you get for answers, and then come back here. Okay, I'm gonna go ahead and put it in. I hope this one shows. I think when I set this up, I was looking at the first one. Okay, and looking at this, it would appear that my answers are 1.5 and 7. Would appear that it's 1.5 and 7. Ta-da! The answers are x equals 7 and x equals 1.5. Now, in a pinch, sometimes you can use that to figure out what the factors were. Okay, so I'll quickly address that. Oh, actually, maybe I can't. Oh, maybe I can. Hang on a second. So you might be able to figure out, okay, that the factors might be x minus 1.5 and x minus 7, because that's what would give you those x-intercepts. And I hope you're also connecting this to an activity we did earlier where we realized that factored form of a quadratic showed you the x-intercepts. But now what you might have trouble with here is that we have never, ever, ever, ever factored something that gave us a decimal. And so that is not how you would answer that. Just for fun, you would have to change this to a fraction, which would be 3/2. And then you'd have to figure out like, oh, that's dividing by 2. So I would have to kind of tweak it and multiply by 2. That's a little weird. And I wouldn't necessarily expect you to figure that out. It's just like one of those things that's out there. If you took that and you solved it, you could get the 1.5 and the 7 from it. So it's just kind of another way to do that with the graphing. You are not getting a pass on your factoring. Your factoring is super crucially important, so you cannot just circumvent all of your factoring. You just have to take your math teacher's word for it on that. But you have this as a backup for when you need it. All right, sorry this video is extra long because I made a mistake, but I do hope that it was worth it for you to see what we did to go and fix, like identify and fix a mistake. If you have questions, make sure you let me know, and I will see you in the next lesson.